Hello students, welcome to my YouTube channel ScopeIIT. Today we will discuss about the topic serializability in DBMS. Okay. Now what do you mean by serializability? Basically, it ensures that concurrent execution of multiple transactions. That means if we are having multiple transaction and we are trying to execute multiple transaction concurrently, okay, so it is possible that they will produce the same result as those transactions were executed one after another in any serial order. Okay, so that is basically known as serializability. Now there are two types of serializability. One is your conflict serialization and another one is your view serialization. Okay, so now first one is your conflict serialization. Now what do you mean by conflict serialization? So a schedule is called conflict serialization if it can be transformed into a serial schedule by swapping non-conflicting operation. Okay. Now here one question will arise, ma'am, what is conflicting and what is non-conflicting operation? So that I'll explain you first. Suppose read. Okay, so read basically is your non-conflicting operation. Why? Because suppose for example, if I'm reading anything, okay, at the same time, if anyone else will come and will read in the same book, so it is possible, right? Two-person can read same data. So similar way, two transactions, if you are just reading it, so it's possible. There is no confliction. Okay. But what are the conflicting operations? So the conflicting operations are read, read, and write. That means, for example, if I'm reading anything, at the same time, someone is editing that transaction or writing inside the transaction. So that will create a confliction. Same way, if other person is writing and we are trying to read the same thing, then also confliction will occur. Okay, because it will lose the updates, right? Then the third one, if I am also writing and other one is also writing the same transaction, so that is also the problem. So these three are basically known as conflicting operation. Okay, these three are known as conflicting operation. So non-conflicting is only one, read, and remaining all are known as conflicting operation. Actually, this conflict serialization, it's very important for your exam. Either you'll give UGC NET, GATE, PGCET, MTech. I think you can expect 99% this question can come in exam. It's very important. Okay. Next, algorithm. Okay. So see, in this algorithm, how to actually will perform this conflict serialization, how to solve the numerical of conflict serialization. So to solve that numerical, we need to follow this algorithm steps. First step, create the number of node in the graph equal to the number of transaction in the given schedule. So that means, for example, if they have given one schedule, in that you are having transaction T1, transaction T2, transaction T3, for example. Okay. So that's what they are telling. That when we are drawing the precedence graph, no, at that time, how many vertices will be there? So that is nothing but equal to the number of transactions. Then, starting with each and every transaction, identify all the existing confliction operation and representing them in the graph in the form of edges following the direction of conflicting operation. So that means, for example, if I got here read write confliction, okay, so there is a confliction from T1 to T2. So when we are drawing this precedence graph, no, T1, T2, T3. Okay, so if we get a confliction, so that confliction will be shown in this precedence graph using arrows. Okay, that's what they are telling in the second step. Third step, check if the precedence graph have cycle or no. So that means after performing all this, suppose I am having arrow from here to here, here to here, okay. So after completing all the confliction arrows and all adding, okay, after that you have to check whether your this precedence graph contains cycle or no. So if it contains a cycle, that means it's a conflict. It is not a conflict serialization. Okay. So see, if a cycle or loop exists, then you can say that schedule is not conflict serialization. And if there is no cycle, that means the schedule is conflict serialization. I hope it's clear. Let us understand this with one example. I have taken one question. Which one of the following schedule is conflict serialization? Okay, so this type of question they'll ask in exam. Now there are four options. So out of this four, we'll see how many are following the conflict serialization. Now how to do? Let us start with option A. Okay, right now I'm solving option A. Now see here. What is the maximum number we are having here? maximum number is 2. So that means how many transactions we will have? We will have only 2 transactions. So transaction T1 and transaction T2. Now, if you see here what they have written, R1X. R1X, that means in transaction T1, it is performing R of X operation. Then W2 of X. So here 2. 2 means it will go to transaction T2. And one more thing, when we are writing it, don't write this W of X here. Okay, it should be written little bit below. The next is R1 of Y. So R1 means it will go to transaction T1. So R of Y. Next is W2 of Y. That means in transaction T2, W of Y. Okay, so this is all. Now you need to check here this one, confliction is there or no. But before that, as per step 1, what we will do, we'll draw the nodes. Okay, so T1 and T2, because there are maximum 2 transactions. No? So we'll draw 2 nodes. Okay, now let us see the confliction. R of X, W of X. I already explained RR is no confliction, RW, WR and WW. These 3 are confliction. Okay. So see R of X, W of X. So that means RW. So there is a confliction from T1 to T2. So confliction is always shown as an arrow. So T1 to T2 there is an arrow. Okay. Now here we already got one arrow. Okay. So don't check for other arrow. Like here you will see R of I, W of I. No need to check. Don't waste your time in that one. Why? Because suppose if you get one more confliction, we are not going to draw one more arrow. We can draw maximum only one arrow between T1 to T2. Now you can check from T2 to T1. Okay, so no need to check further if you get one confliction. Now let us check from T2 to T1. So see, T2 to T1, W of X, R of Y. There is no confliction. WR is a confliction, but it is with different variable. Okay, so with same variable, then only confliction will arise. With different variable, we can do. Next, that's all. Now you might be thinking, ma'am, why you have not checked this one and this one? Because it is down to up. Okay, and we always check confliction only from up to down. We never check from down to up. Okay, so here the confliction is from up to down. I have checked. See, so here also I can check up to down. Okay, I cannot check down to up. So there is no confliction from T2 to T1. I hope it's clear. So as there is no confliction, now check, is there any cycle? No, if you will get confliction from T2 to T1, then cycle will arise. T1 to T2, T2 to T1. But right now there is no cycle. So as there is no cycle, that means it is conflict serialization. What was the question? Which one of the following schedule is conflict serialization? So A is the answer. Other than that, we will even check the other options as well. Okay. Let us check other options also. Option B says that R1 of Y, that means it will be written in transaction T1, R of X, R2 of Y. So, R of Y in T2. W2 of, that means in transaction T2 only W of X, R1 of Y. So, in T1, W of Y. Okay, and please maintain it should be written little bit below. That's why only I was telling. Because we can check only up to down. We cannot check down to up. Now, you can see R of X, W of X. R of X, R of Y is no confliction. R of X, W of X. So, we got one confliction from T1 to T2. So, draw one arrow from T1 to T2. Now, let us check from T2 to T1. So, now if you check here, you can see R of Y, W of Y. It's read write as well as with same variable. So there is a confliction from here to here. So we'll draw one arrow from T2 to T1. Now here you can see there is a cycle T1 to T2, T2 to T1. So it is not CS. So option B is not the correct answer. Okay. Let us check option C also. Now in option C, R of Y, that means in transaction T1, R of X, not Y, sorry. Then W of X. This is also W1. So that means in transaction T1 only, W of X. Then R2 of Y. R2 of Y, that means in T2. R of X. Then last one, W of X in T2 only. So W of X. Okay. So you can see R of X, W of X in transaction T1 both. Then R2 and W2. So both in transaction T2. R of X, W of X. Okay. That means all with X only. Now let us see. So R of x, this is not a confliction. R no confliction. R of x, W of x. So there is a confliction from T1 to T2. So let us draw one arrow from T1 to T2. Now check from T2 to T1. So here you can see T2 both transaction is below. Okay, so we cannot check down to up. Hence, there is no arrow from T2 to T1, no confliction from T2 to T1. So here you can see there is no cycle. So the answer for this one is, so as there is no cycle, so the answer for this one is conflict serialization, because there is no. So what was the question? Which one of the following schedule is conflict serialization? So even C is the correct answer. Now let us check the last option, option D. In option D, R1 of x. So in transaction T1, R of x. R2 of x. So in transaction T2, R of x. W1 of y. So in transaction T1, W of x. W2 of x. So that means in transaction T2, W of x. Okay. Now let us check the confliction. R of x, W of x. So there is a confliction from T1 to T2. Now let us check from T2 to T1. So here you can see R of x, W of x. So there is confliction from T2 to T1. So this is one arrow T1 to T2 and another from T2 to T1. So here you can see there is a cycle. So as it is a cycle, so it is not CS. Okay, so D is not the correct answer. So what's the correct answer for this question? Option A and D. I hope it's clear. So this is all about conflict serialization. Okay. There is one more question that you can try. The given schedule, okay, as R1 of x, W2 of x, R1 of y, W2 of y and W1 of x. Okay. All of you please try this question by yourself first. Okay. Now see. So let us draw the schedule. Okay. What is the maximum number? Maximum number here also is 2. Okay. So T1 and T2. Then R1 of x. So that means in transaction T1, R of x. W2 of x. So that means in transaction T2, W of x. W1 of y. So in transaction T1, R of y. Sorry, not W. Then W2 of y. So in transaction T2, W of y. Then W1 of x. So that means in transaction T1, W of x. In transaction T1, W of x. Okay, that's little bit below I have written. Now let us see the confliction and even we'll draw precedence graph T1 and T2. Okay, so see R of x, W of x. So there is a confliction from T1 to T2. So let us draw one arrow T1 to T2. Now let us check from T2 to T1. So if we'll check here, W of x, R of y. WR is a confliction but with different variables. So this is not a confliction. Then W of x, R of x. So there is even confliction from T2 to T1. So there is even confliction from T2 to T1. So as there is a cycle, okay. So the answer for this question is not CS. Okay, so as cycle is there, the answer for this question is not CS. So the correct answer in this question is option C. Okay. Next, so this is all about conflict serialization. Now, another serialization technique is view serialization. So, a schedule is view serializable if it is view equivalent to a serial schedule. Okay. So, this is very important point that when you can say that the schedule is view serialization. So, the schedule is known as view serialization if it is view equivalent to serial schedule. Then this means that the final state of the database and the value read and return by each transaction are same as the serial. Two schedules are view equivalent. Okay. So first is initial read. So that means first read operation should be performed by same transaction. Then second point is read from. That means for each read operation, the value read is returned by the same transaction in both the schedule. This is the second point. Third point says that the final write, that means the final write on each data item is done by the same transaction in both the schedule. Okay, so that means first read operation should be performed by same transaction. Then last write operation should also be performed by same transaction. And in the middle, we should have a write read operation. So this is the concept that is important for view serialization. So I hope it's clear. In this video, I have covered serializability, There are two types of serializability: conflict serializability and view serializability. So in the next class, in the next video, I am going to cover previous year GATE question and UGC NET question on conflict serialization. So if you like my video, please like and subscribe my channel. Thank you.